Hello friends, welcome back to your UPSC, and today we'll start with our second lecture of geomorphology, that is endogenetic and exogenetic forces which come under earth movement. So let's get started. So endogenetic and exogenetic forces are the factors that affect the earth crust. Okay, so endogenetic forces are the forces which are coming from within the earth, and exogenetic forces are the denudational process originated from the atmosphere, like wind erosion, water erosion, okay, that we'll study later on. So in endogenetic forces, there are two types of forces: diastrophic forces and sudden forces. Diastrophic forces are very slow, and you cannot notice them in your lifespan. Okay, and in sudden forces, they are abrupt outburst of energy causing sudden change, like volcanic eruption or earthquake. They come in sudden forces. Now in diastrophic moment, we'll see that there are two types of forces. First is aperogenetic and second is orogenetic. In aperogenetic, we'll see that the whole continental landmass, okay, whole continental landmass that is greater in area is uplifted or subducted. So they are in, as we have said, they are either uplifted, that is upward movement, and either subducted, that is downward movement. Okay, and in orogenetic forces, orogenesis means formation of mountain. Okay, so these are the forces that causes the formation of mountain. So in orogenetic forces, we have two types of forces, that is tensional force or compressional force. Tensional force causes crustal fracture in two ways. First is cracking and second is faulting. Okay, so cracking is just a mere crack in the rock surface. Okay, and faulting is fracture in the crustal rock, wherein the rock are displaced along the plane. Okay, so in faulting, we will see there are basically six types of fault. They are, first is normal fault. In normal fault, we will see that, okay, I'll show you with the diagram. So this is basic diagram of faulting. In it we can see two rocks. First is upward block and second is downward block. This is strike and this is dip. Okay, and this is hanging wall. This is our dip angle. Okay, so in normal fault, what basically the thing is that the fault plane is at 45-degree angles, is between 45-degree angles and vertical. Okay, so this is either 45 or more. And then next we have reverse fault. In reverse fault, the plates or the blocks, they slide past each other, okay, like this. So we can observe a reverse fault. Now next we can see, I'm sorry, I think I'm out of focus. I'm so sorry guys, I was out of focus. So now we'll start once again. So this is normal fault. In normal fault, we'll see that this block, that is upward block and downward block, they slide over each other. Okay, they slide over each other. One goes down and one goes upward, or one goes upward, sorry, at either 45-degree angle. Okay, so the dip angle is either 45 or more. The next is our reverse fault. So in reverse fault, what happens is, like, these are two blocks. In normal fault, these are the forces which are acting against opposite direction to each other, in opposite direction. So we'll find a crack, and then these two blocks will slide. One will go upward and other will go downwards. Okay, but in this one, that is reverse fault, there is compressional forces. That is, the forces are acting towards each other. So the blocks slide past each other. Okay, so one is going upward in this direction while the other goes in the opposite direction. Get it? So in simple words, we can say that in the reverse fault, the fractured block, they move in the reverse direction. Okay? Sorry, in towards each other. And hence forming the reverse fault. Now the next one is lateral fault or strike slip fault. I told you what is strike. So the normal fault and reverse fault were dip slip fault. Okay? And now the lateral fault, it is strike slip fault. So in it, what happens? When the rock blocks are displaced horizontally along the fault plane. What is fault plane? This is the fault plane. I'm so sorry. This is the fault plane. So what happens is, there is one block, and here we can see the another block. They are not moving upward or downward. They are moving forward and backwards. Okay, so this is strike slip. That is strike. One strike is here and other strike is here. This is strike slip fault, and the first two were dip slip fault. Okay, the next one is step fault. In step fault, it is simple. As the name suggests, there is one normal fault, okay, with one block, and then same type of fault we can see again. So it forms a step sort of structure. We can see steps, okay. These are step faults. Next is rift valley. It is also commonly known as graben. So in graben, what happens? Consider there are three blocks, three fractured blocks, okay. So in rift valley, what happens? These two blocks will start moving in opposite direction, which will cause this one to hang, and because it is hanging, it will go downwards. Okay, so this is how valley is formed, and how we can identify that this one is a block valley. Okay, a rift valley, sorry. The rock structure that you find in this layer and this layer, the same sort of rock structure will be there present in this layer, and then the rock structure found here will be present here. Okay, so this will give us a clear cut indication that this is Rift Valley or Graben. Now next comes Block Mountain or Horst. Okay, so Block Mountain or Horst, they are there are three blocks again. The the block present at the edges, they start coming close to each other. Okay, now this block is compressed. So what will happen? The block will slide upwards, making a mountain-like structure. Okay, these type of mountains are known as block mountains, and they are also known as horst. So I want you to name Rift Valley and block mountains present in India. Okay, so now let's get on to another thing, that is compressional forces. We have done tensional forces. Okay, we have completed tensional forces. Now we are coming up to compressional forces. They cause crustal bending. So the crustal bending is in two forms, that is warping. Warping is of two types: upwarping, that is the crust will upwarp, or downwarping. Okay, and the second is folds. So folds are more important. So now we'll study about folds. So before we study folds, first I want to give you a small definition about folds. So the folds are wave-like bending in the crustal surface of the rock. Okay, so basically we can see two types of fold, that is anticlinal fold, that is upward fold, and synclinal fold. Okay guys, please remember, this is anticline and this is syncline. Okay, the one which is going upward is anticlinal fold, and the second one which is going downwards is synclinal fold. Now we'll study about fold type. So anticline and syncline we have done. Anticlinorium is actually when this, I'll show you a diagram. This is our anticline and syncline fold. When the compressional force goes on and on, so this whole structure will warp up, or it will form a giant fold like this. Okay, so this is known as anticlinorium, and when the same things happen in opposite way, that is downward direction, this is known as synclinorium. Okay, and when these things happen simultaneously, that is anticlinorium and synclinorium are happening simultaneously, that is like this. Okay, like this. So this is known as fan fold. Now the more important folds are symmetrical fold. What happens in symmetrical folds? So in symmetrical fold, what happens is, see, we have compressional forces, equal compressional forces acting from both sides. That is, if it is F1, this is also F1. And the rock structure is even. That is, we are having same type of density and strength. The rock is having same type of density and strength. So the fold will be even. Okay. if we cut it, then the angles will be equal. So this type of fold is known as symmetrical fold, and the opposite is asymmetrical fold, where the force is acting, like if this is F1, this one will be F2. Okay, so one side will be having more bending than the other one, like this one. So this one is having more bending. Okay, so this one, alpha, is greater than theta. Okay, because F1 is less than F2. So this is asymmetrical fold. So why asymmetrical fold happens is that either the forces acting are different, okay, and if the forces are same, then the rock structure is different from both sides. Okay, now next is monoclinal fold. What happens in monoclinal fold is either the we'll see that one side, that one slope is almost about 90 degree or right angle, okay, as compared to other one. This can happen because of three reasons. First is this force, that is F1, is far more greater than F2, okay, or the rock structure of this one is harder than this side, or third thing is that there may be a case that this when this fold was happening, the rock structure in this part was made up of very hard material, which caused this part to bend like this. Okay, so I hope you got it. So these are the three reasons which will cause monoclinal fold. Then is isoclinal fold. In isoclinal fold, what happens is we see a fold, okay, which is inclined towards the ground. Sorry, it is inclined towards the ground, okay, but and both the slopes are parallel to each other, but they are not horizontal to the surface. Okay? The next stage is what is known as recumbent force. In recumbent force, what happens is this fold deepens. Okay, so this fold deepens up, and it deepens so much that this surface and this surface are already parallel. Okay, but they are horizontal too. Okay, like this. So they are parallel and as well as they are horizontal. Okay. Next comes is plunge fold. In plunge fold, what happens is see that this is the axis of the fault. Okay, this what I am drawing. These are the axes of the fault. So due to more compressional force, the axis of the fault, it instead of getting horizontal, it tilts itself. Okay, so this is known as plunge fold. And the next field study is overturned fold. We'll see open fold and closed fold later on. What happens in overturned fold is first we have the simple fold. Okay, the simple fold we have. Then due to intense compression, we will see that this this part, it goes deep inside. Okay, and this is what is known as overturned fold. Okay, So in simple definition of overturned fold are those fold in which one limb of the fold thrust upon the another. Okay, one limb of the fold thrust upon the another one, and the first one another due to intense compressional forces. So these compressional forces are very intense. Okay, now next is Naples. What happens in Naples is, we have understood overturned fold. So due to very intense pressure, these limbs break down. Okay, and they are like, one part is here, okay, then another part goes down here. Okay, so the naples are the result of complex folding mechanism caused by intense horizontal movement resultant of compression forces. Okay, so these two limbs, they break down and they move in opposite direction. Okay, which form, so this part will emerge in another area, okay, which is having totally different rock structure. Okay, so this part will be known as Naples. Okay, and the downward part, it will go somewhere else. Now next, the last two, they are open fold and closed fold. They are simple one. Open fold is what we can see like this. So this angle, okay, so this angle is obtuse angle. Okay, so that is more than 90 degree. Theta is more than 90 degree and less than 180 degree. And in closed fold, this will be an acute angle. Okay, so that is more than 0 degree but less than 90 degree. Okay, so this was all for today. So today we have studied endogenetic and exogenetic forces, faulting and folding. Okay guys, so if you have any query, you can ask me in the comment box, and please like and subscribe my channel, and do comment if you have some problem or if you like the video. Thank you and have a nice day.